For this part of the video, we'll be dealing with another subtopic under the real numbers. So that's going to mostly cover estimations, lowest common multiple, and highest common factor. So LCM, or lowest common multiple. To find the lowest common multiple, you have to express each number as a product of its prime factors, right? And then the highest common factor, or HCF, is the product of the common prime factors. So we're going to look more into the expansion of what this means. So looking back at what a prime number is. A prime number is a number which has exactly two factors. That means it's only divisible by two factors, 1 and itself. 1 itself is not a prime number since it's only divisible by 1 and not something else. 2, however, is a prime number. So you should know maybe the first 5 or 10 prime numbers, right? For example, 2, then 3, 5, 7, 11, 13, 17, 19, 23, 29. When we look at these, we realize that you can only divide 1 and that number without leaving a remainder, not something else. For example, 3 can only be divisible by 1 and 3 without leaving a remainder. Anything else would otherwise leave a remainder. And then now looking into the highest common factor. So what is the highest common factor of two numbers? So a common factor, right, of between two numbers is a number that both numbers can be divided by. So that's just understanding a common factor without leaving a remainder. And the highest common factor is the largest factor then that is divisible into the two numbers without leaving a remainder. So how to find the highest common factor? There are two approaches to doing that. One of those is to list all the factors that are common. Let's say the question asks you to find, let's say it says, find the highest common factor of 24 and 30. So first, let's look at what are the factors of 24. So numbers that are divisible into 24 without leaving a remainder. We have, we can start with 1, and then we have 2, and then we have 3, and we have 4, and we have 6, and we have 8, and we have 12, right? And we have 24 as well. Great. And then we look at the factors of 30. We have 1, we have 2. So it's 2 into 30, that's going to give us 15. 3 into 30, that's 10, so 3 as well. 4 would give us a remainder, but 5 into 30, that's 6, so 5 is a factor. 6 into 30, that's 5, so 6 is a factor. 7 is not, 8 is not because it would leave a remainder, 9 is not, 10 is, 10 into 30, that's going to be 3, 11 is not, 12 is not, 13 is not, 14 is not, 15 is a factor, and then after that 30 is the last factor. So when we look at this, we have factors of 24, right, and we have factors of 30. Now the question is, what is the first of all, we can just look at which factors are common, right? We have 1 in both, so 1. We have 2 in both, so 2. We have 3 in both, then we have 3. We have 6 in both, so we have 6. And nothing else is common in both. So now, what is the highest common factor? So now the highest is going to be 6. So that's one way to do it. You list all the factors for each of the numbers. Be careful not to forget some, and then after that you find then which factors are common in both numbers, and then after that to say what is the highest then, because what's key is to find the highest common factor. Or method number 2, which says write the number as a product of its prime factors first. So this one is a bit different in that, so we had 24 and 30. 24. So to write it as a product of its prime factors, you first have to find what's the lowest prime factor that's divisible into that number, right? So for 24, okay, so we have 24. So for 24, we know that 2 is the lowest prime factor. So then we say 2 into 24, that is 12. Again, the next prime factor divisible into 12, that's again 2. 2 into 12, that's 6. Again, 2 into 6, that's 3. And now the lowest prime factor is going to be 3. 3 into 3, that's 1. So take note that once you have 1 here, you can stop. And the format is you first write the number you're trying to find the product of its prime factors. Then you find the lowest prime factor first. In this case, it's 2. When you say 2 into 24, that's going to give you 12. And then 2 into 12, that's going to give you 6. Right? Then 2 into 6, that's going to give you 3. And then 3 into 3, that's going to give you 1. Once you have 1, you stop. So that means that we can express 24 is 2 times 2 times 2 times 3, which is correct, because when you do the calculation, 2 times 2, that is 4, right? Times 2 times 3. 4 times 2, that is 8 times 3. 8 times 3, that is going to be 24. So just to show you that you can actually go back to find that. So we now know that 24 is a product of its prime factors. It's this range of numbers right here. Okay, great. So now the next, we do the same for 30, right? Because we had 30 and 24. Again, we have 30. So the lowest prime factor that is divisible into 30, that's going to be 2. 2 into 30, that is 15. Then 3 into 15, that is 5. 5 into 5, that is 1. So this is because you have to keep checking what is the lowest prime factor that is divisible into the new number that is forming on the right hand side of that line. So again, that means that 30 is equal to 2 times 3 times 5. And you can cross check this as well by expanding that multiplication, and you will get the same answer. So now the question is, how do we find the highest common factor, right? Between the two numbers. So now we want the highest common factor. So we look into what is common between the two. Again, because it's supposed to be a common factor, right? So we have 2 there and 2 there. So that's 2 times. We have 3 there and 3 there times 3. So then we get 6 as our highest common factor. So you can choose which method is easier to understand or to try, or in this case, you can either write all the factors, taking note that you do not skip any factors, or you can use the prime factors method, where you first express a number as the product of its prime factors and then find which of the prime factors are common in both expansions. So for example, we have another example which says find the highest common factor of 42 and 90. So we do the same thing. We have 42 and we have 90. So we're supposed to first find the prime factors. So number 1, so I'm going to use the method of prime factors in this case. So first, prime factors. So for 42, 2 into 42, that is 21. 3 into 21, that is 7. 7 into 7, that is 1. Take note that I'm taking all these are prime factors, right? Take note that they are prime factors. And we do the same for 90 as well. So we have 90, 2 into 90, that is 45. 3 into 45. So you always have to take the lowest prime factor. I know that 5 is also a prime factor and it's divisible into 45, but it's not the lowest one, right? In this case. So 3 into 45, that is 15. 3 into 15, that is 5. 5 into 5, that is 1. So when we look at it, 42 is then 2 times 3 times 7, which is what we have here. 90 is 2 times 3 times 3 times 5, which is what we have here. So that's what we have, and that's what we have. So now either you can even write in a Venn diagram where you write that for 42 it is 2, 3, and 7, and for 90 is 2, 3, 3, and 5. What is common between them is 2 and 3, or in this case 2 by elimination, where we say what's common. 2 and 2, 2 times 3 and 3, 3 again. Then the highest common factor is going to be 6, 2 times 3. And then when we now look at the lowest common multiple, firstly, a common multiple of two numbers is a number that appears in both their timetables, right? And the product of two numbers is always a common multiple. So for example, if we had to find the lowest common multiple of 12 and 10, then 10 times 12 is always a multiple, which is going to be 120. It might not be the lowest. In this case though, what we need to find is the lowest. So take note that you can't just multiply two numbers and say that is the lowest common multiple. It is going to be a multiple, but now you have to find what is the lowest common multiple. And this is useful when you're subtracting and adding fractions as well, to find the lowest common multiple or highest common factor. So how do you find the lowest common multiple between two numbers? So let's take an example. So there are two methods as well as for finding lowest common multiple, just as we had two methods for highest common factor. So to find the common multiple, one of the methods involves writing down the multiples of each number. Then the multiples of a common multiple of two numbers will also be the common multiples, right? So for example, 60 is a common multiple between 12 and 10. So let's say we have been asked to find the lowest common multiple between 12 and 10, right? First, we say multiples of 12, then multiples of 10, right? So multiples of 12 and multiples of 10. So which are the multiples of 12? 12 times 1, that's 12. 12 times 2, that's 24. 12 times 3, that is 36. 12 times 4, that's 48. 12 times 5, that is 60. 12 times 6, that's 72, and on and on and on, right? And then now we look at multiples of 10, right? 10 times 1, 10 times 2, 20, times 3, 30, times 4, 40, times 5, 50, times 6, 60, times 7, 70, and on and on and on and on and on. Taking note, okay, maybe we can we can try expand this to more numbers. So times 7, that's 84. Then times 8, that's 96. times 9, that's 108, times 10, that's 120, and on and on and on, right? And then here we have 70, 80, 90, 100, 120, 130, and on and on and on, right? So when we look at it, we can keep going because multiples of a number can go up to infinity. But what we need is the lowest common multiple. Firstly, let's just look at some common multiples we can see right now. So we already have 60 and 60, and we have 120 and 120. All right. But then the question is, what is the lowest? So then the lowest common multiple for 12 and 10 is 60. Right. We have some common multiples between 12 and 10. So numbers which are divisible by both 12 and 10 without leaving a remainder. If we had kept expanding that, we have 60, 120, 180, 240. It goes on and on and on. But what we need in this case is the lowest one. So for the lowest one, then 60 is the answer. So method number 2 involves writing both as a product of the prime factors. So again, we have 12 and 10, right? So 2 into 12, that's 6. 2 into 6, that's 3. 3 into 3, that is 1. 2 into 10, that is 5. 5 into 5, that is 1. So that means that 12 is equal to 2 times 2 times 3, while 10 is equal to 2 times 5. And to find then the lowest common multiple, this is a different way compared to the highest common factor. Is when something is repeated, we only write it once. So we have 2 in both, so that's going to be 2 times. Then we write the rest of the factors that remain. So we have 2 times 3 times 5, right? And now we expand this. 2 times 2, that is 4, times 3, that is 12, times 5, that's 60. So then it is much easier in this way, I think, compared to writing the multiples of the numbers. Unless for some numbers you easily get to the lowest common multiple, but for some numbers it could expand to higher digits. So you can choose whichever method is easier or which one you understand. So be careful how many times you write a prime factor, how many times it appears. So if it's common in both 12 and 10, then you only write it once. For example, these 2, we wrote it once, and then the ones that remained, we leave it. We then write them down. You can also use a Venn diagram if that helps. So again, we had 42 and 90. If we had asked to find the lowest common multiple, we do the same way, 42 and 90. 2 into 42, 21. 3 into 21, that's 7. 7 into 7, that is 1. 2 into 90, that is 45. 3 into 45, that is 15. 3 into 15, that is 5. 5 into 5, that is 1. So now we have 42 being equal to 2 times 3 times 7, and 90 being 2 times 3 times 3 times 5. So remember, when you put it in a set, the numbers that are overlapping, you do not repeat them. So now, multiplying it to find the lowest common factor, we have 2 times 3, is common, 2 and 3 are common in both, then times 7 times 3 times 5. So that's here, 7 times 2 times 3 times 3 times 5, and 630. So imagine if you were writing the multiples of 42 and 90. that can easily get to be a lot, because now you're going to have 90 times 1 times 2, 180 times 3, 270 times 4, 360 times 5, and it just goes on and on and on and on. And it can easily expand, and 42 is even more tricky, because now you're dealing with numbers that require you to potentially use the calculator at some point, and it goes on and on and on and on. So then in this case, it is much easier to use the prime factors method. And for additional notes, you can also refer to the textbook. If you have access to the mathematics textbook, book 3, page 6 to 8, they also have a lot of examples and some practice questions that you can give a try. And as an exercise, I also extracted some of those questions, and you can try to find the highest common factor and lowest common multiple of these. Number 1, which is 32 and 40. Number 4 has 3 numbers, 24, 36, and 90. Number 5 has 30 and 45. Then number 8 has 78, 108, and 390. So finding the lowest common factor and highest common multiple of those 4 numbers. So you can take a screenshot, give them a try, and if you have any questions or need access to the solutions, you can also reach out in the comments. And I can also do some additional examples. For example, this question says, find the lowest common multiple of 18 and 24. So what we can do is we can do both methods, just so that you can choose whichever one you prefer at the end of the day, whichever one works for you. So we have method 1, that is expressing each of these into their multiples, right? So we have multiples of 18. That's going to be 18 times 1, 18 times 2, 36, times 3, 54, times 4, 72, times 5, 90, times 6, 108. Okay, I can go on and on. And then multiples of 24 times 1, that's 24, times 2, that's 48, times 3, that's 72. So at this point, I've already realized that there is a common multiple. So I don't need to keep going, which is going to be 72. So then the lowest common multiple of 18 and 24 is 72. That's using method number 1. And now, if we use the method of prime factors, so we have to express each as a product of its prime factor. So we have 18 and we have 24. 2 into 18, that's going to be 9. 3 into 9, that's 3. 3 into 3, that is 1. 2 into 24, that's 12. 2 into 12, that's 6. 2 into 6, that's 3. 3 into 3, that's 1. So now we have 18 is equal to 2 times 3 times 3, and 24 is equal to 2 times 2 times 2 times 3, right? So to find the lowest common multiple, again, we write down the prime factors where if one is repeated, we don't write it twice, we just write it once. For example, let's start with the ones that are common in both. We have 2 times, then we have 3 in both, 3. Then what remains, we multiply 3 by 2 by 2. And if we say 2 times 3, that's 6. 2 times 3, that's 6, times 3, that's 18, times 2, that's 36, times 2, that's 76. So sorry, that's 72. So there we go. We have 72 from one of these methods. So you can choose which method works better for you or which method is easier. And the next question says, find the highest common factor of 24, 56, and 72. Again, highest common factor, so we can use one of two methods. So method number 1 is finding the factors of each, right? So factor of 24, factors of 56, and factors of 72. So 1, 2, 3, 4, 4 into 24, and then 5 is not divisible in 24 without leaving a remainder. 6 is a factor, 7 is not, 8 is a factor, 9 is not, 10 is not, 11 is not, 12 is a factor, and then 24. And then 56, we have 1, 2, 4, 7, 8, 14, 28, and 56. And then for 72, we have 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. So now the question is, what is the highest common factor? And when you look at it, 8 is the highest common factor. 2 is a factor in all of them, but it's not the highest. 4 is a factor in all of them, but it's not the highest. So in this case, 8 is the highest common factor. So then the highest common factor is 8. And now we look into the next method using prime factors. Method number 2, expressing each number is a product of its prime factors. And in this case, we have three numbers. We have 24, we have 56, and we have 72. Great. So 2 into 24, that's 12. 2 into 12, that's 6. 2 into 6, that's 3. 3 into 3, that is 1. 2 into 56, that's 28. 2 into 28, that's 14. 2 into 14, that's 7. 7 into 7, that's 1. 2 into 72, that is 36. 2 into 36, that is 18. 2 into 18, that is 9. 3 into 9, that is 3. 3 into 3, that is 1. So now that we know that 24 is equal to 2 times 2 times 2 times 3, and 56 is equal to 2 times 2 times 2 times 7, while 72 is equal to 2 times 2 times 2 times 3 times 3. What is the highest common factor, right? So we need to look at factors that are common in these three. So 2, to start with, is common in both. Again, 2 is common in all three. Again, 2 is common in all three. And that's it. All right, and 2 times 2, that's 4 times 2, that's 8. So now our highest common factor is 8, which is the same as we found when we expressed all the numbers by their factors. So those are the two ways that you can find highest common factor and lowest common multiple. You can choose whichever one is easier, whichever one you understand. And for more examples, you can also refer to the textbooks that are available or used in most of the questions for the ZIMSEC syllabus.